Welcome to another episode of Software Explorations, Concept and Overviews, hosted by your truly tech coach, Ralph, where we are, above all else, engineer twin. In today's episode, we're going to be talking about the Fibonacci sequence using Fibonacci pointing in the story pointing process in Agile, all right? We just went over story pointing last week, but I wanted to break down a little bit more about the most commonly used way of story pointing, which is the Fibonacci sequence. So that's what we're going to do today. But before we go any further, do me a big favor. Like the video, share the video, subscribe to the channel, hit the notification bell so you know every time that we go live and drop new content, as well as go to techcoachralph.dev. Sign up today, sign up for exclusive content, sprint reviews, Scrum nights, how I use LinkedIn, Glassdoor, AI, so many different things, so many different tools, how I use my calendar, updating my resume. I'm going to be doing that live next month in November, as well as sign up for one-on-one coaching where we can work together and I can help you run it up. The spots are very, very limited. They're filling up fast, but get it today, sign up today, and get one-on-one coaching from me. All right. With that being said, let's jump into the presentation for today about the Fibonacci sequence using Fibonacci for story pointing. All right, let's jump into it. Like I said, we're going to be talking about the Fibonacci sequence, estimating effort, time, and complexity effectively. And it's not an easy thing to do. I mean, it gets easier over time, but getting the hang of it, breaking it down, it takes some time to understand. All right, so let's go. So our agenda for today, we're going to do a quick recap of our software experience from last week, story pointing recap, and then we're going to get into like the intro to the Fibonacci sequence, why use the Fibonacci sequence, mapping tasks to Fibonacci. We're going to do an example of estimating stories. We're going to talk about how Fibonacci helps with better planning, some challenges and best practices when using the Fibonacci sequence, and then we're going to wrap it up with our conclusion. All right, let's jump into it. So, story pointing, extending a quick recap, right? So story pointing is not meant to do like how much time it's going to take, but it's more on the relative effort, right? So we're estimating pretty much the level of effort. Is it really, really hard? Is it? It's not that if it takes really, really long, because you can have something that's easy but takes long, but it's really, is it hard? Is it medium, or is it easy, right? And sometimes it correlates to time, but not necessarily. Something could be very easy, but it takes a long time, or something can be very hard, but it takes a short amount of time, right? So we're basing it, so it accounts for complexity, risk, and uncertainty. It helps teams focus on work size rather than hours. An example with setting up CI/CD pipelines versus updating a single config file, right? Setting up CI/CD pipelines can be on the complex side. There's some stuff that you may not be certain about, but updating a single config file, it should be pretty easy. There is some testing involved, so you got to take that into account too. So that's pretty much breaking down the story pointing from a nutshell. However, I am going to pin a link right here, to the breakdown that we did last week. We went in depth into story pointing, so definitely want to check that out. You can watch it right after this one if you're not familiar with the story pointing. If this is your first time watching one of these videos, you can go and check that out, and then just go through the whole Agile process that we've been having for maybe about the past 2 months now. Definitely want to check that. All right, so let's keep going. So the Fibonacci sequence, all right? So the series in the Fibonacci sequence goes 0, 1, 2, 3, 5, 8, 13, 21, and 34, right? Each number is the sum of the two preceding numbers. It's common in nature, mathematics, and the Agile framework. So what do they mean by the sum of the two preceding numbers, right? So 0 and 1 is going to be 1. And now 1 and 1, or 1 and 2 is going to be 3. So now when you do 2 and 3, that's going to be 5. When you do 5 and 8, it's going to be 13. When you do 13 and 21, it's going to be 34, and so forth. You never get to a 34 point. You barely ever get to a 21 point. 13 should be the max. But that's just explaining the level of effort. The reason that it's done this way is because I was explaining last week is that 1, 2, and 3 means somewhat low level of effort. The 3 is about a medium. It's like not super easy, but it's not super hard. It's like right in the middle, right? But then you don't want to go to a 4 because you won't be able to tell the difference between a 3, a 4, and a 5. So now we have that spacing between the 3 and a 5, where 5 is getting a little bit more complex, right? But then now, instead of having 2 points between 5, you have 3 points. So now it's like it's saying, okay, this is getting tougher and tougher. So you're separating out the level of effort, the difference, because in that way you can better gauge how complex something is. And then 8 to 13, there's a 5 point difference in there because and now you can say, okay, where this helps you is now in the future when you're using, like when you're looking back on the points that you use to point, you can say, okay, we pointed this a 13. And now, based on that 13 that we pointed in the past, now we have this upcoming work that is similar. We can properly estimate. So now we're like not making like these crazy estimations and things like that, right? So it's a way of spacing out your estimations so that you can be more accurate in your predictions moving forward. So each number is a sum, common in nature and mathematics. All right, so the story of the Fibonacci sequence, right? The Fibonacci sequence, while named after Italian mathematician Leonardo da Pisa, also known as Fibonacci, it was first described in Indian mathematics around 200 BC by Archeya Pingala, where it appeared in relation to patterns of Sanskrit poetry, right? Fibonacci introduced the sequence to Western mathematics in his year of 1202 book, Liberace. Okay, cool. All right. So why use the Fibonacci sequence? So like I was trying to break down a little bit earlier, right? So nonlinear growth models how task complexities grow. They don't grow on a linear sequence. So that's why we're breaking it down 0, 1, 2, 3, 5, 8, 13, 21, 34, and so forth. So it encourages meaningful discussion, forces prioritization between small and large efforts. So the group is going to, like the team is going to decide what's small, what's large, and we can determine that based on the points that we use. So last week I showed a brief example of using planning poker, and you can see the different points on there. So you'd have the 5 versus the 8 versus the 3. And then it avoids false precision. And this is the key part, right? Estimating 7.3 versus 8 points. What does 7.3 means? Like estimating a 7 and an 8. What's the difference? So giving that gap so you can really say, okay, this is harder than this. So if you point something as a 5, and now you're going to point something as an 8, now you're asking yourself, is this much more complex than the 5, or is it relative, or so that's the idea for it, where it helps account for uncertainty in larger tasks. So Fibonacci values 2 stories. 1 point, very simple task. Example, a small bug fix might be like a 1-line change, very easy to test. 2 to 3 points, minor features or task with low complexity, very easy to understand. 5 to 8 points, moderate complexity or involves multiple steps. So it might be complex, might take a lot of different running around, might touch a couple of different repos, might involve a lot of testing, things like that. 13 points, large features or tasks with dependencies, and these are where you start looking to break them down. You really don't want to get into a 13 because it might eat up your whole sprint. Might have so many different moving pieces. So in the 21 or higher, likely too big and should be split. That's how I feel about the 13s as well. Sometimes even about the 8s, but you can get by with 8. But a 13, it starts to go crazy. All right. So here are some real world estimation examples. Right. So as a user, I want to reset my password. So now the team might discuss it. They might say, okay, there's we already have all the infrastructure done. This is just going to send an email that hits the API to reset the password. Send an email. So low level of effort, all the infrastructure is already there. 2 points. So next up, as an admin, I need to generate monthly reports. So based on what's already set up, we can discuss it. Do we need to pull from different databases? Do we need to run some different SQL queries? But if the infrastructure is there, the team might talk about it and say, okay, compared to resetting the password, and compared, this might be a 5-point story. But could be a 3. It just depends, right? Could be an 8. So now it says, as a user, I want I want a mobile app for notifications. This is getting more complex. If it's building the whole app, well, it's going to be a whole project. But let's say just the notification part of the app. It might be a more complex domain. The team might be new to working on the mobile app. So you might estimate this as a 13. It just depends at the end of the day. It's a relative estimation for the team. You can't compare how one team points a story to how another team points it. because and as I mentioned before, as a team is working together for the first time, they might actually point higher, and as they start to build some cohesion, then their points might start getting lower. So the pointing and the Fibonacci sequence in what you choose for your pointing when you're pointing your task and your stories, they're going to gradually get lower as the team works better. But then now, let's say a new member of the team joins or a couple new members, the points might get higher again because there's going to be some time to adapt. So enabling better planning. So how does the Fibonacci sequence enable better planning, right? So velocity tracking, the sum of completed story points in a sprint. So all the points that were pointed via the Fibonacci sequence, they're going to be added together to see how much you actually got done versus how much you didn't get done. So it's going to help estimate, like we spoke about last week, help estimate how much work can fit into the sprint based on your past however many sprints. It's going to calculate what your average velocity is, and then now it's going to set what you should be committing to for your next sprint. And then it allows better release planning and forecasting. So you can say, all right, if we can get out a solid 20 story points every sprint, we should, and we have our stories pointed for the next couple of sprints, we should be able to release this in the next, month or two, right? So what are some common pitfalls and tips and best practices tips to use when using the Fibonacci sequence, right? So avoid using it as an exact science. It is definitely not exact science, because I'll tell you this, right? As long as my team has been working together, we still get our points wrong sometimes. And then in our retrospective, we come back to, we probably should have pointed this a little higher, but we live and we learn. We live and we learn, and then we go from there, right? Don't estimate too many high point stories, split where possible. That is 100% true. I'm always like, one of the things that we do, and shout out to my Scrum Master who always keeps us honest with this, is if we point something 8 or higher, we always ask, is there any room to split this story down to make it a little bit smaller? And sometimes there's not. There's not going to be any value added if we split it. But we always have to ask. We say if it's an 8 or higher, we ask, can we split this? And when it gets like a 13, there are 99.9% of the time, there's opportunities to split the story to make it more to work better. We can add smaller incremental value, and which is going to lead to bigger value overall, right? Use team agreement and collaboration over time, use team agreement and calibration over time. We want to get to consensus. Like sometimes, like someone might think this is a 3, someone might think it's an 8, and you just have to argue in the right way why this is the appropriate step, this appropriate point. And sometimes you might think that it's a 5 or a 3, and the team might think it's an 8, and you just say, all right, cool, go with it, and we'll learn from that moving forward. You should never have to die on some sort of a story point, right? So discuss, collaborate, calibrate, and move on, right? And then lastly, use planning poker to encourage participation and avoid bias. I showed the example of planning poker last week. Very, very helpful. Definitely recommend, if you haven't tried it, you can sign up for Parable for free to try it out, see how planning poker works. Even if it's by yourself, it's very, very important that you get familiar with planning poker and get an understanding of maybe write some stories and set up Jira, write some stories, use planning poker and estimate them yourself, and go from there. So that's it for today. Very, very short episode, but let's wrap it up. We had a quick recap on story pointing. We spoke about the intro to Fibonacci, why people use Fibonacci sequence, mapping tasks to Fibonacci. We looked at some examples of different stories and how they might be pointed, how Fibonacci is used for better planning, some challenges and some best practices to succeed in story pointing and story refinement and using the Fibonacci sequence. So with that being said, if you have any feedback, if you think I can go in depth in something more on this, do not hesitate to leave me a comment, reach out to me, send me an email, all that good stuff. You can even call in on Tuesday nights if you want some more elaboration, but I am here for you. We're going to go back to full screen now. So thank you guys for tuning in. I really, really appreciate it. That was our quick breakdown of the Fibonacci sequence. Very, very popular and important thing that it would be much, much better if you were to learn this now and understand it as you're getting into your job before you actually get into the company, and now you're totally lost when they're pointing, and then you're pointing 21 for everything. It's not going to work out too well, right? Take it seriously, make it work, and ask questions. And you can ask me any question, and I promise I'll answer you, right? with that being said, we're going to wrap it up for today. Thank you guys so much for tuning in. Do me a favor, if you haven't done so already, like the video, share the video, subscribe to the channel, hit the notification bell so you know every time we go live and drop new content, as well as go to techcoachdrop.dev and sign up for free. We have exclusive content where I'm sharing with you the smart reviews that me and the Tech Barbarians do. I'm sharing with you how to use AI efficiently, how to use LinkedIn, Glassdoor, how to use your calendar so that you can have ultimate success, and you can even sign up for one-on-one coaching, where I will work with you one-on-one, help you to organize your life, get your learning down so that you can get to the next step to get the job that you want or grow in your career. That is at techcoachdrop.dev. Sign up today. Like I said, you can sign up for free and then upgrade from there. I'm going to get out of here. Thank you guys for tuning in on this wonderful, wonderful Wednesday. You guys enjoy the rest of your week. This is Tech Coach Ralph. We are out.
Scrolling through my phone, I can't find a spark. Each day feels like a bug in a broken arc. But my lines of code know me better than they do. In love with these scripts, they hold me true. Conversations fizzle, hearts feel like a chore. Bad dates come and go, but the code's always there. Lines of love in the night, pulling me from despair. These fleeting connections can't break through the strain. I'm lost in these programs, I'm coding my pain. Dining on hopes, but the vibe feels so wrong. Wondering if I can fix what's taking too long. But while dinner gets cold, my thoughts start to race. I'd rather be debugging in my own safe space. Is it me or the code that keeps me awake? Bad days come and go, but the code's always there. Lines of love in the night, pulling me from despair. These fleeting connections can't break through the strain. I'm lost in these programs, I'm coding my pain. Okay. Dining on hopes, but the vibe feels so wrong. Wondering if I can fix what's taking too long. But while dinner gets cold, my thoughts start to race. I'd rather be debugging in my own safe space. Is it me or the code that keeps me awake? Awake, awake. Bad dates come and go, but the code's always there. Lines of love in the night, pulling me from despair. These fleeting connections can't break through the strain. I'm lost in these programs, I'm coding my pain. So I lay down my